Hello students, I am Savita Bhardwaj, PGT Chemistry from Kendriya Vidyalaya number 1 Udhampur, and today I am going to discuss oxoacids of halogens from the P block element. Before starting with oxoacids of halogen, you should know what is an oxoacid. An oxoacid is a compound whose molecule contain at least one hydroxyl group bonded to an atom that in turn is doubly bonded to at least one oxygen atom. C. An oxoacid is a compound whose molecule contains at least one hydroxyl group. That molecule should contain at least one hydroxyl group, means one OH group that is linked to an atom that is doubly bonded to at least one oxygen atom. As you can see in this figure of fluoric acid, it contains at least one hydroxyl group. So here is one OH group, and this hydroxyl group is attached to an atom that in turn is attached to doubly bonded oxygen atom, right? So all those compounds which has at least one hydroxyl group, and that hydroxyl group is attached to an atom, and that atom in turn is attached to at least one oxygen atom through double bond. Those compounds are called oxoacids. Now see, all halogens, they form oxoacids of different type. But fluorine is the only halogen which forms only one oxoacid. That is, fluorine forms only one oxoacid, which is HOF. And we call HOF as fluoric acid or hypofluorous acid. As you can see in this HOF, this is hypofluorous acid, or you can call it fluoric acid. Here bond angle between OH and OF bonds is 97.2 degrees 97.2 degree, and bond length of OF is 144.2 picometer, whereas bond length of OH is 96.4 picometer. Bond length of OF is longer as compared to that of OH because of repulsion between lone pair present on oxygen and fluorine. Both oxygen and fluorine contain lone pair. There is repulsion between those lone pair. Because of that, the bond length increases. That's why OF has longer bond length as compared to OH. Now see, only fluorine forms oxoacid because fluorine has high electronegativity, and also fluorine is smaller in size. Of all the halogen, fluorine is smallest in size and it has high electronegativity. Because of these two reasons, fluorine forms only one oxoacid. It does not form other oxoacids, right? There are four types of oxoacids of halogens depending upon the oxidation state of central halogen atom. First one is hypohalous acid, in which oxidation state is 1. First one is hypohalous acid, in which oxidation state of halogen is 1. We call it halic 1 acid also. Second is halous acid, in which oxidation state is +3. Next is halic acid, in which oxidation state of halogen is 5 +5, and last one is perhalic acid, in which oxidation state of central halogen atom is 7. Right? So depending upon the oxidation state of central halogen atom, oxoacids are classified into four types: hypohalous acid, halous acid, halic acid, and perhalic acid. As I have already told you that fluorine forms only one oxoacid, and we call that as hypofluorous acid. We call that as hypofluorous acid HOF. The rest, it does not form any other oxoacid. For chlorine, There are four types of oxoacid. Hypochlorous acid, as we have already discussed, hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. For bromine, there are hypobromous acid, bromic acid, and perbromic acid. And for iodine, similar to bromine, hypoiodous acid, iodic acid, and periodic acid. So these are the oxoacids of halogens. Now see, I'll discuss the structure of oxoacids of chlorine. Rest are similar to these. First, see structure of hypochlorous acid. This is structure of hypochlorous acid. Second one is structure of chlorous acid. Here, in chlorous acid, there is one hydroxyl group, at least one hydroxyl group that is attached to a halogen, and that halogen is attached to a doubly bonded oxygen, right? Next one is chloric acid. Chloric acid. Here, chlorine is bonded to one hydroxyl group and rest two doubly bonded oxygen. As you can see from here, oxidation state of chlorine will be +5 because doubly bonded oxygen means it has -2 charge, it has -2 charge, -4, and OH has -1. So if I'll calculate oxidation number of chlorine, it will come out to be +5. Last one is perchloric acid. In perchloric acid, there is one hydroxyl group attached to central chlorine atom, and that chlorine atom is further bonded to doubly bonded oxygen atom. There are three doubly bonded oxygen atoms, and for all these three, oxidation state will be -2. So total for oxygen is -6, -1 for OH. It means chlorine will have oxidation state of +7. That's why it is called perchloric acid. So you have to remember that depending upon oxidation state, there are four types of oxoacids, right? And in chlorous acid, it is +3, and in hypochlorous acid, we have +1. These are the oxoacids of chlorine. Now, see, most important and which is generally asked in exams also, acidic strength of oxoacids. You should know what is the order of acidic strength of oxoacid. Here you can see there are four oxoacids of chlorine, as I have discussed earlier: hypochlorous acid, chlorous acid, chloric acid, and perchloric acid. And I have also told you oxidation state of central atom in all these four. First one will have +1, 3. Second one will have +3. Third will have +5. And in fourth, oxidation state of chlorine is +7. So acidic strength of oxoacid of same halogen increases with increase in oxidation number of the halogen. What does it mean? If I have taken same halogen, here in all four oxoacid, halogen is chlorine. It means when I'll compare the acidic strength of oxoacid of same halogen, that is chlorine here, acidic strength will increase with increase in oxidation number of the halogen. They are saying that as oxidation state is increasing, it means that acidic strength is also increases. But why it is increasing? What is the effect of oxidation number of halogen on the acidic strength? As you can see here, as the number of oxygen bonded to central atom increases, the oxidation number of the atom increases, causing a weakening of the OH bond strength and an increase in the acidity. You know, acidic character means how easily an oxoacid can lose its H positive. It will tell about its acidic strength. So weaker the OH bond, stronger will be the acidic strength. When OH bond will be weaker, when it will be connected to electronegative oxygen atom. More the number of electronegative atom, more it will attract the central atom towards itself. As a result, OH bond will become weak and H positive can be easily lost. So, the main reason that acidic strength of oxo acid increases with increase in oxidation number of the halogen is that as the number of oxygen bonded to central atom increases, the oxidation number of the atom also increases, which causes weakening of OH bond strength and hence an increase in the acidity. So this is an important question which is generally asked in exam related to acidity. Similar questions is being asked for oxidizing property of these oxo acids. See, oxidizing power of oxo acids. So increasing order of oxidizing power of oxo acid is from perchloric acid to hypochlorous acid. It is just reverse of acidic character. See, as the stability of oxoanion increases, its tendency to decompose to give oxygen decreases, and hence its oxidizing power decreases. Since the stability of oxoanion decreases in the order as mentioned here, therefore oxidizing power of their oxo acid increases in the reverse order. As you can see here, when oxo acid will lose its H positive, it will form what? It will form its conjugate base. Now we have to see the stability of this conjugate base. These are generally what? Because they have lost its H positive, so it will acquire negative charge. Or we can say that we will check the stability of the oxoanions, and the stability of oxoanion depends upon the number of doubly bonded oxygen atom attached to central atom, that is halogen. More the number of doubly bonded oxygen atom, more will be the delocalization of negative charge, and hence more is its stability. It means because perchloric acid had maximum number of doubly bonded oxygen, that is 3, it means that it will have negative charge which will be delocalizing on 3 oxygen atom which are doubly bonded. So out of all these oxoanions, perchlorate ion will be highly stable due to more resonating structure, and hypochlorous ion will be less stable. It means as the stability of oxoanion increases, its tendency to decompose to give oxygen, it will also decrease. It will also decrease because that negative charge is delocalized on oxygen atom, it will make it more stable. So tendency to decompose to give oxygen decreases. And since tendency to give oxygen decreases, it means that oxidizing power will decrease. Because oxidizing power means it will give oxygen to others, and if its oxidizing power is decreasing, it means it is unable to provide oxygen atom, right? So oxidizing power of the oxo acid increases in the reverse order. So oxidizing power will be maximum for hypochlorous acid and it will be minimum for it will be minimum for perchloric acid, right? So this was all about oxo acids of halogen. Thank you so much.